Hi everyone, I'm Dinuth back again with another video on Kubernetes. Today we are discussing on Kubernetes Services, Ingresses and Networking Policies. If you are planning to sit for Certified Kubernetes Application Developer CKAD exam, this is all you need to know for the services and networking domain, which gives you 13% of marks during the exam. So without further ado, let's get it started. When you deploy pods in Kubernetes, each pod will get an IP address. But if a pod crashes or is deleted and a new pod is created in its place, it is most likely to receive a new IP address. So when your application components need to talk to each other within the Kubernetes cluster using pod IP addresses, actually it is not practical. In addition to that, when you are using deployments or replica sets to deploy your application, there will be more than one pods running at a moment. So you need another layer to group these pods together as a networking service, such that networking service will load balance the traffic and provide a DNS name to access all of these pods. Look at this example. You have the same app deployed in pod 1, 2 and 3, and it is running on port 8080. All pods of this app has the same label app. The value is my app. To allow other pods or the apps to access these pods as a group, we create a service. Service name is my app. Service port is 80. Target port is the container port. To which ports do I need to send the traffic if I receive a traffic on this service port 80 is defined with the selector by providing the pod labels. So once you have the service in place, the other ports in the namespace will be able to connect to this my app service with the service discovery using the service name. Hence, it is http://myapp-port80, and then this is called as the internal service discovery. In Kubernetes, service discovery is implemented with auto-generated service names that maps to the service's IP address. This is handled by kubedns, which is the DNS server inside the Kubernetes cluster. Within the same namespace, you can access the services directly with the service name, as you see in the example, http://myapp-port80. But if you want to access the services in another namespace, you will be accessing it with the service name .namespace.svc.cluster.local. Kubeproxy service, which is running in each node, will make the forwarding traffic rule configurations in each node such that when you receive a traffic into the service's IP address, it will send that traffic into the match pods with the selector labels. There are multiple types of services. Let's discuss these service types one by one. First service type is ClusterIP. ClusterIP service type enables a virtual IP inside the cluster to enable the communication between the apps inside the cluster. As you see in the diagram, service will get the internal cluster IP. Client port can connect to the below ports through the cluster IP service IP address, as well as the DNS name as we discussed earlier. Assume that you have an Nginx deployment which is running inside the cluster like this. So you create the deployment with kubectl create, deployment, Nginx, and you pass the image, port, and the replicas. So once you create the deployment, you will have the pod labels with app. The value would be Nginx. We need this information to configure our service. We can create a cluster IP service to expose this deployment with this command, kubectl create service cluster IP, and then you will be providing what is my service name, Nginx service, and afterwards you need to provide --TCP, what is the port, and then what is the target port in that container. And you can export this service definition using dry run client and then -o YAML. So the YAML definition of the cluster IP service would look like this. and then you can see the kind is service, and then you have the service name app. Under the spec type, you can see the service type is cluster IP. If you don't define a type, by default it will be considering as a cluster IP service. And then under the selector, you need to define what is my deployment pod labels. So in that case, as we mentioned a little earlier, my deployment will have the labels app nginx. So in that case, I need to make the change here, app nginx instead of app nginx service. And afterwards, under the port section, you will be defining what is my port name, some arbitrary name you can provide, and then you will be providing the port, and then what is my target port, and afterwards you can provide my protocol. Example here is TCP. So once you have the YAML file ready, you can create this service using kubectl create -if and the file name, and then the service will get created. To get the services, you can use kubectl get services command. The short form is svc. And once you get the service, the cluster IP address, you can see it in the output. When a service is created, internally Kubernetes creates an endpoint resource to proxy the traffic to the pods based on the selector labels. So you can check the endpoints which is created by the service using kubectl get endpoints command or kubectl get ep. Under that, you can see when we make a call into the service where that traffic will be routed to. You can see all of these 3 ports IP addresses as well as the port when you list the kubectl get endpoints command. You can try out this service with a busybox pod like this, kubectl run busybox --image busybox, and then I want to remove this pod automatically after running this command. Because of that, I'm including --rm, and then interactive mode -it, restart never, and then I'll be executing the wget command with the http:// my service name nginx service. So once you execute that command, you will get the nginx homepage output in the console. So in addition to the URL, you can use the services cluster IP address as well in this wget command. In that case also you will get the same output. In the exam, if you are asked to create a pod and expose it with a cluster IP, you can do both pod creation as well as the service creation in a single command like this, kubectl run, and then your pod name. Let's say if you are asked to create a Redis pod, and then you will be passing the image, Redis, and then whatever the additional commands, and then you can mention the port, and then when you put --expose, in addition to the pod creation, it will create a cluster IP service and then expose this pod as a service. You cannot use this --expose flag with the kubectl create deployment commands. So once the deployment is created, you can expose the deployment using another command like you see in the screen, kubectl expose deployment and the deployment name. And then you can provide what is my service name using --name flag. And the type of my service is cluster IP, and my cluster IP service port is port 80. Target port, that will be the container port, would be port 80. So when you run this command, it will expose the current deployment by automatically picking up the deployment pod template labels as the selector and then create the cluster IP service. You can use the same command with expose pod to expose an existing pod as a service. Next service type is NodePort, which is built on top of the cluster IP service type by exposing the cluster IP service outside the cluster on high ports of the worker nodes. So the default port range would be 30,000 to 32,767. If port number is not specified when you are defining the NodePort service, so the Kubernetes will be automatically picking up a free port number and then assigning it to the NodePort service. Local kube proxy is responsible for listening onto this port on the nodes and then forward that traffic on the NodePort to the cluster IP service. So what are the use cases of having a NodePort? NodePort can be very useful when you are manually configuring external load balancer to forward the layer 4 traffic from the clients outside the cluster to the particular set of pods which are running inside the Kubernetes cluster. So in such cases, the specific port number that is used for the NodePort must be set ahead of time, and the external load balancer must be configured to forward the traffic to the listening port on these worker nodes. So you can create these NodePort service with kubectl create service NodePort and the service name. You can provide nginx, and in the same way like previous, ---- TCP, what is my service port, colon, then what is my target port, and then additionally you can define the node port. What is the node port do I need to use for the service using ---- node port. If you don't define the node port flag, in that case, Kubernetes will be automatically picking up a free port for you. So the NodePort service YAML file would look like this. The only difference is the type would be NodePort, and then you can define the NodePort's address under the port section. So to expose an existing deployment or a pod, you can use this command as well to create the service. Type would be in this case NodePort. And then need to highlight this point, you cannot define the NodePort number with this kubectl expose command. So in that case, if you want to use this command, you need to export it with the YAML definition, and then in the YAML definition you need to make the required changes and then do the apply. Right, so if you have not yet subscribed into my channel, please do hit on the subscribe button with the bell sign to get notified when I upload new videos. So let's start the next service, the load balancer service. This load balancer service type is built on top of the NodePort service type by provisioning and configuring an external load balancer from public or the private cloud provider. It exposes the services that are running in the cluster by forwarding layer 4 traffic to the worker nodes. This is a dynamic way of implementing a case that involves external load balancer and NodePort type of services. However, it is usually requires an integration that runs inside the Kubernetes cluster that perform a watch on the API for the service type of this load balancer. So here is an example. So in that case, the Kubernetes API should know how to configure the AWS Elastic Load Balancer using the AWS APIs. You can create the load balancer service with kubectl create load balancer, and then you can provide the service name, and then you can provide ---- TCP, what is my service port and what is my container port. To expose an existing deployment or a pod as a load balancer service, you can use the kubectl expose deployment command as well, but in this case, the type would be load balancer. There is a service type called external name to map a service to a DNS name rather than mapping it to a set of pods by selecting with selector labels. So one of the example is you can create an external name service called database, pointing to a database server that might be running outside your Kubernetes cluster. So when your applications wants to access the database, rather than using the lengthy name of the database original DNS name, you can use database instead of the lengthy DNS name of this database, right? So that's all you need to know about services, and let's move into the next topic. It is not practical for a user to access the application from node IP address and then high range of node ports. There are scenarios where you need to expose the application with externally accessible URL with a domain name on HTTP or HTTPS with SSL configurations as well. In this scenario, you can use ingresses, which can expose HTTP and HTTPS routes from outside the cluster to the services within the Kubernetes cluster. Traffic routing is controlled by the rules defined in the Ingress resource. Ingress controller and Ingress resources will handle these functionalities, and Kubernetes will not come with the Ingress controller by default. So if there is no Ingress controller set up, Ingress resources will not work. So there are many Ingress controllers available that you can pick and choose based on the private and public cloud environment that you have. Nginx Ingress controller is a widely used Ingress controller which can be used in private cloud as well as with AWS, Elastic Kubernetes Service, EKS, Google Kubernetes Engine, GKE, as well as in Azure Kubernetes Service, AKS. There are other Ingress controllers as well. So if you're looking for an Ingress controller other than Nginx Ingress controller for AWS, Elastic Kubernetes Service, EKS, you can use AWS Load Balancer controller from AWS, as well as Zalando also has a Kube Ingress controller which works with the application Load Balancer. And if you're looking for an Ingress controller for Azure Kubernetes Service, you can use Azure Application Gateway Ingress controller as well instead of the Nginx Ingress controller. As you see in the diagram, when a client sends the traffic into the Ingress controller managed load balancer, the request will be routed to the service based on the routing rules that you have defined in the Ingress definition. So here is an example YAML definition for an Ingress. In this example, kind is Ingress. You can define all the rules under spec rules section. Host can be defined in the host section, but the host section is optional, and all paths can be defined under HTTP path section. Here there are two paths configured, /foo and /bar. When a request comes to myapp.com/foo, it is routed into foo service on port 4200. When a request comes to myapp.com/bar, it is routed to bar service on port 8080. So path type is defined as prefix, which do the path machine based on the URL prefix. Additionally, path type can be defined as exact to match the URL path exactly. And also please note that these paths are case sensitive. Ingress controller supports different Ingress configurations which can be enabled by adding different annotations. These annotations will get differ based on the Ingress controller that you are using. In this example, this is related to the Nginx Ingress controller. What it does is it rewrites the URL to / when the traffic is routed to the service. Now let's discuss about networking policies. Kubernetes has all allowed networking rule by default. So pods in all nodes, all namespaces can communicate with each other without configuring any routes using IP addresses or the pod DNS names or the services. When you have multi-tier application where you have a web tier, app tier, and database tier, having this kind of open network connectivity between all of these tiers is not a good security best practice. You need to limit and control these access between the tiers or different components of your application. When you're defining a network connectivity, you will be defining two types of traffic. Who can send me traffic, and then to whom that I can send the traffic. So you will be defining that using ingress and egress. So as an example, when you're creating a network policy for a web tier, so the ingress traffic can be allowed from all IPs if your web tier is accessible from internet, and the egress traffic is the web tier is sending the traffic to the app tier. And then if you are creating the network policy for the app tier, in that case, web tier can send the traffic into the app tier, as well as app tier can send the egress traffic into the database. If you want to configure a network policy for the database, so database will be accessed only by the app tier ports. In that case, you will be limiting the ingress traffic into the database ports from the app tier ports. When you define these web tier, app tier, and database tier network policies, now you have the full control of who can connect to what services, and you have the required networking security in place. Now let's look at how to create a network policy with the YAML definition, and this YAML definition can be found in the Kubernetes networking policy documentation. If you look at this YAML definition, under spec pod selector section can be used to define which pods this network policies needs to be attached to. So if you are creating a network policy for the database pods, check the database pods labels and include those labels here under the spec port selector section. And each network policy includes a policy types list, which may include either ingress, egress, or both. When the ingress is included, that means you need to control the ingress traffic to these selected ports, and the egress is included, which means you need to control the egress traffic from these selected ports. When you define both, that means you need to control both ingress and egress traffic. Afterwards, you can define ingress and egress rules. When you are defining ingress, you can have multiple rules. Under each rule, you can have two parts, from and ports. A rule can have one of these or both of these. From will be used to define from which IPs, from which namespaces, from which ports the traffic can be received. IP block section is used to define the IP addresses, as the CIDR ranges, and namespace selector section is used to define the namespaces from where traffic can be received by defining the namespace labels. In the same way, the port selector section is used to define the ports where the traffic can be received by defining the port labels. Additionally, a rule can have port section, which is used to define which ports you want to allow for this ingress traffic. In the same way, you can define egress traffic. So only difference is, instead of using from, you will be using to instead. So let's take an example in our 3-tier application example. I have my production application deployed in prod namespace, and I need to create a network policy for my app tier ports. My app tier ports has the label role app. So in my port selector, I define those labels. This is where this network policy will be applicable to. For the ingress traffic, right, that means who can access these app tier ports. I need to allow ingress traffic from the pod namespace and web tier ports, so that I'm defining it with the namespace selector and the port selectors. My app tier is serving traffic on port 8080. So in my network policy, I restrict the ingress traffic so that this port can only receive the traffic. So in that case, if the web tier tries to access any of the other ports in my app tier, it will by default get denied. Now we are going to the egress section. In the egress, I have two egress rules defined. My first egress rule is to allow the traffic to the database ports which has the role DB label. My database is MySQL serving the traffic on port 3306, so I include the port restriction as well to restrict the traffic only into that port. Second egress rule is to enable the Kubernetes service discovery when the app tier ports want to reach the other services database ports with the database service DNS names. DNS resolving egress traffic will go through port 53. So in that case, I'm allowing all port 53 on TCP and UDP traffic as well. Otherwise, service discovery egress traffics will get failed, and then you will not be able to reach the database ports using the service names. In the same way, during the exam, either CKA or CKAD, you will be asked to create network policies. Try to understand to which ports do I need to apply this network policy, and then from that point of view, decide what is my ingress traffic and then what is my egress traffic. Based on that, make the configurations in your network policy. That's all we are discussing in this video. I hope now you have a better understanding on Kubernetes services and different service types such as ClusterIP, NodePort, LoadBalancer, external names, and then we discussed ingresses and network policies as well. So if you enjoy this video, don't forget to hit the like button and share this with your friends as well. If you have not yet subscribed into my channel, please subscribe followed by the bell sign to get notified when I upload new videos. Thank you so much. See you again in another video. Until that, bye bye.